In this RStudio video tutorial, we'll be learning how to assess whether or not a distribution is normal using QQ plots or quantile-quantile plots. For the purposes of this course, a QQ plot will be used primarily to determine if a distribution is normal. So I've already loaded our data frame into R. It's called wine. Let's briefly look at it with the head function. We see 6 variables, and we know that there are 175 rows in this data frame. Of these, 1, 2, 3, 4, 5 are numeric, and the first one, cultivar, is a categorical variable. So when you make a QQ plot, you use the function QQnorm. And what this does is it plots the theoretical quantiles of a normal distribution along the x-axis and the actual quantiles of our data on the y-axis. So let's go ahead and look at a QQnorm plot for malic acid to determine if the distribution of values in malic acid are normal or not. So we see this is a normal QQ plot, R samples quantiles on the y-axis and theoretical normal quantiles on the x-axis. Now I'm going to use QQline, which is going to add in the theoretical line along which the values should lie if the distribution were normal. And to be sure I can distinguish it from the points, I'm going to make it the color red. So if the distribution were normal, all of our points would lie on this line, which is in fact an x equals y line, where the sample quantiles and the theoretical quantile values would be equal. So since we see the majority of points, in fact almost no points, are lying along this expected distribution, we can conclude that the distribution of malic acid values is not normal. If we were going to analyze malic acid with various hypothesis tests, then we would want to prefer non-parametric methods. So again, this is not a normal distribution. Let's look at a different variable, like this time hue, which is just a scale of colors that the wines might be. So this is the QQ plot. Now in order to assess whether it's normal, let's add on a QQ line. Again, color equals red. For this plot, we see that while there are some points which do not specifically lie on the line at the ends, the vast majority, in fact almost all points, do lie on this line. This tells us that the hue variable is most likely normally distributed. Therefore, if we want to assess it with hypothesis tests, we can use parametric methods. Now, if we really wanted to use parametric methods for the malic acid variable, which remember was not normal, we can try to do a transformation of some kind. A common transformation is a log transformation, where we take all of these values in malic acid and take their logarithm, and then reassess the distribution to see if it is now normal. So first we'll make a new variable called log malic, and we'll save to that the log transform values of malic acid. And now what we'll do is we'll make a QQ plot of log malic, and then add on our QQ line for log malic color equals red. Points are much closer to the line now than they were before. However, it is not perfect. The distribution of malic acid was definitely not normal, and the log malic acid, while it is approaching normal at this point, is still not fully normal. So while you might be able to get away with parametric methods, for this course we recommend that you do use non-parametric methods when analyzing your malic acid variable, as the log transformation did not seem to help the situation. And this is how you can verify your assumptions for normality with QQ plots.